So these are sum and difference formulas. This will be given to you on the test. So you don't have to memorize them, you just have to know what to do with them. So looking at example 1, it says find the exact value of cosine of 75 degrees. I'll do that here. Is 75 degrees on our unit circle? No, it's not. So we want to use our sum and difference formulas to come up with two angles that equate to 75 degrees that are on our unit circle. So looking at our unit circle, we've got angles like 30, 45, 60, 90, 120, 135, 150, and so on. Which two angles on our unit circle will either add or subtract to 75 degrees?
Something less 45.
45 and 30, perfect. So this is like saying cosine of 45 degrees plus 30 degrees. Now we can't just find the cosine of 45 and add it to the cosine of 30. It doesn't work that way. We have to use one of our sum and difference formulas. So cosine, and we're adding, would go with this one, cosine, and we're adding. So we're looking at this part of our formula. So the first number is going to be our u. The second number is going to be our v. So this is the cosine of u, which is 45 degrees, times the cosine of v, which is 30, minus the sine of u, so sine of 45 degrees, times the sine of v, which is 30. Now, if you said 45 plus 30 or 30 plus 45, it doesn't matter. Your answer will end up being the same. So as long as your two angles add or subtract to the one that's given. Now, once we put it in our formula, here we just have to find each one of these. So cosine tells us we look at what on the unit circle? X. So where is our x value, or what is our x value at 45 degrees? Square root 2 over 2. Perfect. So this is square root 2 over 2. Cosine of 30 now. Cosine tells us we look at the x value. What's our x value at 30 degrees? Square root 3 over 2. It's a little bit blurry. Minus sine of 45. So sine tells us we look at what on the unit circle? Y. What's our y value at 45 degrees? Square root 2 over 2. And then sine of 30, sine tells us we look at the y value. What's our y value at 30 degrees? 1/2. So once we find each one of these trig functions, we just multiply and then subtract together. How do I multiply fractions? Straight across. So square root 2 times square root 3 would be square root 6, and 2 times 2 would be 4. Minus square root 2 times 1 is square root 2, and 2 times 2 is 4. So square root 6 minus square root 2, since these are like terms, so we have a common denominator, not like terms, but we have a common denominator, we can subtract them. We have square root 6 minus square root 2 over 4. So this would be our answer. So for B, we're looking for the sine of pi over 12. Question?
No.
Pi over 12 is a little bit harder to figure out which two angles on our unit circle add up to pi over 12, but we can just convert it. Let's convert it to degrees. That way we can just use the degrees on our unit circle. How would I convert pi over 12 to degrees? Multiply by 180 over pi. So pi's cancel. 12 goes into 180 how many times? Or what goes into both 12 and 180? 6 goes into 12 2 times, and 6 goes into 180 30 times. So it's 30 divided by 2. 15. Awesome. So now we're looking for the sine of 15 degrees. Which two angles on our unit circle add up to 15 degrees? Add or subtract.
0 and 15.
15 is not on our unit circle.
45 and 30.
45 and 30. We can subtract them. So this would be sine of 45 minus 30. That would give us 15. So now we can use our sum and difference formulas. We're looking for the one that has sine with a minus in the middle. So looking at our formulas up here, sine with a minus in the middle would be the second equation. So the first number is going to be our u, second number will be the v. So sine of 45 times cosine of 30 minus cosine of u, which is 45, times sine of 30. From here, let's look at our unit circle. Sine tells us we look at what? The y. What's our y value at 45 degrees? Square root 2 over 2, perfect. What's our cosine? Tells us we look at what? The x. What's the x at 30 degrees? Square root 3 over 2, perfect. Minus cosine of 45. Cosine tells us we look at what? X. What's our x at 45 degrees? Square root 2 over 2. Times sine of 30. What's our sine? What's our y at 30 degrees? 1/2. So let's multiply these and subtract them together. So when we multiply fractions, just multiply straight across. Square root 2 times square root 3 would be what? Square root 6. 2 times 2 is 4. Minus square root 1 times square root 2 times 1 would be square root 2. And 2 times 2 is 4. We have a common denominator, so we can just subtract these together. So we get square root 6 minus square root 2 over 4. It just so happened that it's the same answer as the last question, but that's not always going to be the case. All right, example 3. It says to write as a single trig function and evaluate. So we're kind of doing the same thing we just did in example 1, but backwards. So here we want to look at the right side of our formulas and see which one it matches, and then we're going to use the left side. So which of our formulas goes sine times cosine with a plus sign in the middle? So looking at our formulas, which one goes sine times cosine with a plus sign in the middle? The first one. Sine times cosine with a plus sign in the middle. So we're using sine of u plus v. Now the first number is going to be our u, and the second number is going to be the v. So this would be sine of 74 plus 16. What's 74 plus 16? 90. So sine of 90 degrees. So this is the first part of the question. Write as a single trig function. This is writing it as a single trig function. Second part is we have to evaluate. So let's go to our unit circle and see what the sine of 90 degrees is. So sine tells us we look at what?
Y.
The y. What's our y value at 90 degrees? 1. Awesome. So sine of 90 would be 1. So that would be our answer. Let's do B. So for B, our equation goes cosine, cosine, plus. Which of our formulas here goes cosine, cosine, plus? The last one, cosine, cosine, plus. So that's cosine of u minus v. So the first number is going to be our u, second number is going to be the v. So this would be cosine of 280 minus 40. So cosine of 240. So this is the first part of our question coming up with the trig function. Second part is we have to evaluate. So we have to go look for this on the unit circle. Cosine tells us we look at what? The x. So what is our x value at 240 degrees on the unit circle? Negative 1/2. Awesome. So this would be negative 1/2. All right, last one, let's do C. So here we have a tangent. Tangent, we only have two options to choose from. And it's tangent with a plus sign on top. Which one has tangent with the plus sign on top? The first one. So tangent of u plus v. First number is going to be our u. Second number is going to be the v. So this would be tangent of 190 plus 125. So this would be the tangent. What's 190 plus 125? 315. Yeah. Tangent tells us we look at what on the unit circle?
X over y.
Y over x. So we want to see what is y over x at 315 degrees. So let's go to 315 degrees. We already found this the other day, but in case it's not going to give you this on the test. So let's figure out y would be negative square root 2 over 2 over our x, which would be square root 2 over 2. When we keep, change, flip, what do we get? What do we get? What do you get when you divide the same thing by itself? Negative 1. Perfect. So tangent of 315 would be negative 1. So this would be our answer. So example 2 involves what we're doing now, but also what we've done in the past. So sine, it gives us u here. Sine of u is equal to 4 over 5. Sine we know is what in terms of x, y, and r? Well, in terms of x and y, what is it? Y. Thank you. So it would be y over r. Because here it's not on the unit circle, so in the other questions that we were doing, y is on the unit circle, so r is just 1. But here we have y over r. And then it tells us where u is in between 0 and pi over 2. Well, if we drew our unit circle, our first quadrant would be from 0 to pi over 2. Quadrant 2 would be from pi over 2 to pi. Quadrant 3 would be from pi to 3 pi over 2. And then quadrant 4 would be from 3 pi over 2 to 2 pi. So which quadrant are we in from 0 to pi over 2? Which quadrant? Quadrant 1, because we're from 0 to pi over 2. So this just tells us we are in quadrant 1. So we want to find what's missing. So u is our angle here. That's kind of the triangle that we're talking about. We know that y is 4, r is 5. So we're missing x. We need to find x. How do you think I could find x? Pythagorean theorem. Awesome. So we'd say x squared plus y squared equals r squared. It's always equal to your r squared. R is the radius. Remember, r is always positive. So let's use our Pythagorean theorem. X squared plus 4 squared equals 5 squared. So x squared plus 16 equals 25. Subtract 16 on both sides. X squared equals 9. So what does x equal? X equals 3. Perfect. Now in quadrant 1, we got to think about it. What's positive in quadrant 1? What's the acronym that we use to tell us the signs? All students take calculus. So what's positive in quadrant 1? Everything. If I had my triangle over here, I've got a positive x and a positive y. They're going in the positive direction. That is backwards. A positive y, because y goes up, and a positive x, because we go to the right. So everything's positive in quadrant 1. We're going to pause on quadrant 1, or on our U angle triangle here. Let's do our triangle V. So we've got two different triangles, but for the same question. So we want to find everything for V. So cosine would be what over what? X over R. Awesome. Does the negative go with the X or the R? The X, because R is never negative. It's always positive. So X equals negative 12. R equals 13. And we need to find Y. Now let's figure out what quadrant are we in here. From pi over 2 to pi, what quadrant would that be? Quadrant 2, perfect. So in quadrant 2, we know that all students take calculus. In quadrant 2, if I had my triangle here, X is going to be negative and Y is positive because Y we go up. So our Y is positive. We don't really need to do anything else. We already know that our X is negative there. So we're good. Let's find Y. How would we find Y? Pythagorean theorem. So negative 12 squared plus Y squared equals 13 squared. Be careful with your signs here. When we square negative 12, it's positive 144. And 13 squared would be 169. Subtract 144 on both sides. Y squared equals 25. Take the square root. What does Y equal? 5. Perfect. And we said it was going to be a positive Y. So positive 5. So this is all of our important information for triangle V. Now going back to the question, it says find the exact value of sine of U plus V. So we're going to use our sum and difference formulas. We're looking for the one that's sine of U plus V, so that would be this one. So I'm going to write it out. We have sine of U times cosine of V plus cosine of U times sine of V. So we got that from our sum and difference formula. From here, we're going to plug in. So sine of U, this tells us we're looking at triangle U. Sine is what over what? Y over R. So our Y over R would be 4 over 5. Cosine of V tells us we have to look at triangle V. Cosine is what over what? X over R, so that would be negative 12. It is X over R, so that would be negative 12 over 13. Plus cosine of U, so we got to look back at our U triangle over here. Cosine's what over what? X over R, so our X was 3 and R is 5. And then sine of V, we look at our V triangle here. Sine is what over what? Y over R. So our Y was 5 and our R is 13. From here, we're going to multiply and then add them together. So when we multiply fractions, we multiply straight across. 4 times negative 12 would be what? Negative 48. 5 times 13 is 65. Plus 3 times 5 would be 15. Over 5 times 13 is 65. So when we add our numerators together, negative 48 plus 15 would be what? negative 33, perfect, over 65. That would be our answer. Can we simplify? Oh, no, we can't. So super important. You want to use the given information, find your two triangles. So we had triangle U. We had to find all three of our key numbers, X, Y, and R for U. And then we had triangle V. So we had to find X, Y, and R for triangle V. And then use your sum and difference formula and plug in.